Okay, so this is my supercarbon project by Andrew Pearl, and I did polymers. And the definition of polymers is that it's a substance that has a molecular structure consisting chiefly or entirely of a large group of similar united bonded together. That is monomers that are bonded together. And many synthetic organic materials used as plastics and resins are polymers. They exist in natural and synthetic forms. For the history of polymers. Polymers have been around since the existence of time, but they've existed in natural forms. Some natural forms that existed were tar, shells, horns, and tree saps. In 1920, Hermann Staudinger, a German chemist, wrote a paper about polymers. He formulated a structure for rubber and received the Nobel Prize in 1953 for his contributions to the study of polymers. And he is credited with the discovery of polymers because of his work. The process that is involved with polymers is called polymerization. It's the process of converting a monomer to polymers. And the monomers, as you can see here, are the little tiny features that make up the chain once they're converted over, and the chain is the polymers. Polymer chains can be increased when unsaturated monomers react to form an extended polymer chain. Physical properties. Generally, here are some physical properties of polymers. Generally, polymers have a lighter weight, but they make up for it with extreme strength for the size. Such as many plastics we see today, they're light, but they are fairly strong and don't break easily. Polymers are also very flexible and can be processed in various ways, shapes, and forms. They have almost limitless range of characteristics and colors. They can come in pretty much any type. And here are two examples of some polymers, specific polymers. One is PVC, the density being 1330, and the tensile strength of 48. Another polymer is polystyrene, which has a density of 1050 and tensile strength of 20 to 30. Here are some chemical properties of polymers. Hydrogen bonding between the chains of polymers improves the strength, which the strength is directly related to the higher crystalline melting points that occur in polymers. Polymers can also be resistant to many other chemicals. They also have chemical properties that allow them to be great thermal and electrical insulators. Synthetic polymers are usually made up of petroleum too. They don't always have to, but generally they are. And the nomenclature rules for polymers include that there's two types. One being the source-based nomenclature, the other being the structure-based nomenclature. The source-based nomenclature is used when the monomer of the polymer is identified. The structure-based nomenclature uses a preferred constitutional repeating unit to determine nomenclature, which is they dissect a piece of the polymer, the chain, and they take that pattern to determine the nomenclature. And examples of polymers we see today are cellulose, which exists in natural form, and cellulose is usually found in wood and paper. And it includes all types of plastics, because they basically are plastics. DNA is a polymer, most rubbers, and proteins, like proteins we find in our hair, nails, and shells of usually animals. Uses of polymer. Polymers are used in all plastics, which have become increasingly popular during the past decade. Polymers are basically plastics alone, and plastics have grown to overcome wood, metal, and glass because it is cheap to make and is still durable. And the 3D diagram of a monomer I have here is chromium trioxide, the chromium being right here, and the trioxides being the red balls. And many of these monomers make up a polymer just in a large chain, but it's too big to create itself, so here's a monomer. Done. This is the summary for my supercarbon project now. The first one starting with alcohol, and here you see is a picture. The definition of alcohol is an organic compound in which the hydroxyl functional group, negative OH, is bound to a carbon atom. In particular, this carbon center should be saturated, having single bonds to 2 or 3 atoms. The next one, alkyl halide. Definition: a compound with the type formula RX, where the R is an alkyl group and the X is a halogen. Ether. Compound in which an oxygen atom is bounded to 2 alkyl or 2 aryl groups, or 1 alkyl and 1 aryl group. Aldehydes. An aldehyde is an organic compound containing the negative CHO functional group at the end of a hydrocarbon. It also refers to the aldehyde functional group R negative CHO appearing at the endpoints of the molecules. Ketones. A ketone is a compound containing a carbonyl functional group bridging 2 groups of atoms. Carboxylic acids. And any organic compound with a general chemical formula COOH, in which a carbon C atom is bonded to an oxygen O atom by a double bond to make a carbonyl group. Esters. An organic compound made by replacing the hydrogen of any acid by an alkyl or other organic group. Many naturally occurring fats and essential oils are esters of fatty acids. Amines. Organic compounds and functional group that contains the basic nitrogen atom with a lone pair. Amines are derivatives of ammonia, wherein 1 more hydrogen atoms have been replaced by a substituent such as an alkyl or an aryl group. Amides. An amide is a functional group containing a carbonyl group or a nitrogen atom. Amide also refers to any compound containing the amide functional group. Amides are derived from carboxylic acid and an amide. And lastly, polymers, which I happen to do. The definition being a large molecule consisting of chains or rings of linked monomer units, usually characterized by high melted and boiling points. And lastly, here's an MSDS of polymers, material data safety sheet from company PSS, and it's just general safeties and warnings about polymers.